Hi everyone, my name is Priyanka Taneja. I'm a software engineer with SAP Labs. I have around 9 years of experience and I have worked with organizations like GE and JP Morgan before. And I have been mentor with few of the edtech companies and I have 2 years of mentoring experience. So today I'll be talking about different kind of problems in array and how we can categorize those problems and how we can identify the pattern and how we can approach those problems. So I'll be talking about it. I'll be sharing my screen. Okay. So we'll be talking about different approaches in arrays and how we can identify the arrays problems and how we can categorize it. So there are different approaches in arrays, like 2 pointers, sliding window, prefix sum, and the carry forward. So we'll be talking about sliding window problems today and a part of prefix sum as well. So I'll be talking about these problems. So let's move to the particular problem. So given an array of integers and a number k, find the maximum sum of sub-array of size k. So we have given an input array and a k equals to 4. And we need to return the maximum sum sub-array. We need to return a sub-array which gives us the maximum sum. In this case, 4, 2, 10, 23, which is of size 4, is returning the maximum sum, which is 39. So we need to return the 39. So if we think about the problem, array problem, we first need to think about the brute force, how we can solve it. So let's think about the brute force approach. So what I will be thinking of is I'll calculate all the possible subarrays and I'll calculate the sum of it and I will pick the maximum sum out of it. That will be the basic brute force approach where I'll be picking up all the subarrays. So if I take that, what is the pros and cons of that approach? Let me move to the next slide. So if I pick up all the subarrays and calculate the sum and find the maximum out of it, what will be the time complexity and space complexity in that particular case? In that particular case, the time complexity will be n square because I'm comparing each and every element again and again. So it will give me the n square time complexity. But we are good at the space complexity part. We are not taking any additional space. So that's why our space complexity is constant. But we can't go ahead with the n square time complexity. We need to think about it. So this is the code I have written for the brute force approach. You can start with the brute force approach and slowly and gradually you can optimize it and you can improvise on it. So yeah, moving to the next slide. Can we optimize it? Yeah, we can. So let me talk about a prefix sum. What is prefix sum? Let me explain you what is a prefix sum. This is another approach which we commonly use in arrays problem, where we maintain a separate array which keeps a track of the prefix sum. So if I talk about this original array and a prefix array, my prefix array will maintain my sum till that particular point. If I consider at 0th location, my sum would be 1. Till my position first, my prefix sum would be 5. Till my position 2, my sum is 7. So I need to maintain a separate array where I'm maintaining the sum, which we call it as a prefix sum array. And we use this prefix sum to calculate the different problems, or we use this prefix sum to get the result. So if I calculate as part of the last problem which we discussed, right? So we have a k equals to 4. If we calculate the first 4 sum and then we keep on moving the pointers by 1 and reducing 1 pointer from the beginning, can we get the result? Right? We can. Like the sum of last 5 elements is 40. Right? To calculate the last 4 elements, we need to subtract 40 minus 1, right? Before the start of the window. So 40 minus 1, 39. So the sum of 5, 7. So the sum of 4, 2, 10, 23, it gives us the sum of 39. So that is what the prefix sum is. So if I talk about here, like if I talk about this approach, we are using a prefix sum array where we are storing all the previous elements sum till that particular point and we are using it. So now if I talk about what is the pros and cons for this, if we want to go through the code, I have written the code. This is the code. So I'm taking another prefix sum array where I'm maintaining the prefix sum and utilizing that in one single iteration, I'm able to get the result. I'm able to get the maximum sum, right? So what is the issue with this approach? Yeah, we improved on the time complexity part, but we increased the space complexity. We came to the time complexity of big of n, but we increased the space complexity as well because we have used an additional array, prefix sum array. But yeah, can we optimize it further? Can we improve on the space complexity part as well? Because we are good on the time complexities. Yes, we can. So here comes the optimal approach, which is the sliding window approach, along with the prefix sum. See, in the previous approach, we were using a prefix sum array. Here, we'll not use a separate array. So first thing is when we can use the sliding window approach, when you have a fixed size of window. In this, I have a fixed size of window 4. If I have a fixed size provided, like the window size is 5 or 10, I have a fixed size of window I can take, which I can slide from here to there, right? In that particular case, I can use sliding window. And along with the sliding window, we mostly use the prefix sum approach. We keep track of the prefix sum and utilize it. So sliding window and prefix sum comes hand in hand. So that's what this one is the optimal approach. Let me explain you how we can optimize it further. So what I am trying to do is I'm calculating the sum of first 4 elements, which is my window size k equals to 4. I'm taking a size 4 and I'm calculating the sum. In the max sum, which was initially 0, I have assigned it to the sum which I got max till now. Okay, so now I have slid my window by 1 pointer and I have calculated the sum plus 23. My sum variable will have the new element added to it, which is 23. And now we need to subtract the previous element, which was 1. So when I subtract it, I am doing the 39. I'm getting 39. So the work which I was in the second approach, I was doing with the help of a prefix sum array, right? Now I'm doing that similar kind of work, but a single variable with the help of a variable. So I saved my space, right? I am not using any additional data structure here. I have saved my space and my space complexity improved here. So I will continue till my last pointer, my sliding window reach till the end. So I will be moving my pointer to 3. I'll be increasing pointer by 1. And then I'll be adding sum plus 3, then minus 4, whatever is the last one, right? So I'll be getting 38. But the max one, whatever was the max, was 39 till that point, right? Again, I'll be moving by 1 pointer. Then I will be adding 1 to it and subtracting 2 from there. So the sum would be 37 and still the max is 39. So I will be continuing doing it till my window reach till the end of the array. So my window reached till the end of the array and my maximum sum which I obtained is 39. So I'll be returning the 39 out of it. So this is the optimal approach, which is the goal for this. I just used a single loop. This is my first loop where I'm calculating the sum array till k, like the sum of first 4 elements, which I need to have for the keeping the track of the sum. Then I'm using another loop starting from k and iterating till the end of the array. So I'm just using a single loop and getting the max sum sub array out of it. So that's how I improved the time and the space complexity. So what is the time complexity? Big of n, as I'm just doing it in one iteration. And in the terms of space complexity, we are not using any space additional. So the space complexity is big of 1. So that's how we have done it. So if I would explain it again. So how do we identify the sliding window? How do we identify the question? If you have a fixed size of window, in that case, you need to use the sliding window approach and you need to use prefix sum along with it. In most of the cases, it works. In some of the cases, it doesn't work that way. But yeah, if you have a fixed size of input like k equals to 4, k equals to 5, in that case, try to use sliding window and try to get the solution out of it. Yeah. So that's what I have for the day. Thank you so much.